So good afternoon, everyone. Thank you for giving me this opportunity to MLR Institute of Technology. So today we are going to discuss about ANSYS ACP tools. So in this session, I'm going to explain the stress analysis of composite in T-beam. So I will tell you how to connect ACP tools to static structural and how to do post processing. So let's begin. So I'm using ANSYS is 18.1. So now everyone can see my screen, right?
Yes, it's visible.
Yeah. So this is the front screen of ANSYS. So from this, we have 5 sections. One is toolbox, project schematic, and its properties, and the taskbar. So in this toolbox, we will be having analysis systems, component systems, custom systems, design exploration, and external connection systems. So in this, I'm going to use ACP pre to design a composite laminate. So we just click ACP pre and drag it here in the project schematic. So it will contain 5 cells. One is engineering data, geometry, model, and setup. So first we need to choose our material. So what are the material we are going to use for our analysis? So for that, double click on engineering data. Once you double click on engineering data, you'll be getting engineering data desktop. So our default material is structural steel. So now we are going to choose a composite materials. So what are the things we are going to use in our analysis? For that, here you can see engineering data sources. So click on engineering data source. Once you click on engineering data source, you will find a different data source here. General materials, general non-linear materials, hyperelastic, materials you will find in data source in this library. So I'm going to select composite material here. Once you select composite material, you will get the materials in the library, in the composite material libraries. So these are the materials you will find here. Epoxy carbon unidirectional, prepreg, wet. So glass, epoxy glass, honeycomb, PVC. So different materials will be having here. Suppose the material it's not there, what are the material you want? You need to create your own material. For that, you need to edit here. So here you can add a new library. What are the materials you want, or else you can add your own material. So I'm going to use default materials. I'm not going to use any materials here. So uncheck this box. So I'm going to use epoxy S glass unidirectional and honeycomb. It's a core material, and resin epoxy is a matrix. So 3 materials I'm going to choose here. If you want, you can check those properties. What is the density of that particular material and other properties. So once you select these materials, you can check here. You can find the contents. What are the things you selected there? Epoxy, S glass, honeycomb, resin epoxy. These 3 materials I'm going to use for our analysis. So now our material selection is over. So let's move to geometry. So here, right click on geometry. You can see new space claim geometry and new design modeler. I'm going to use a design model here. Yeah? So click on design modeler. Once you click on design modeler, you can get a notification at the left bottom. So starting design modeler. Okay, this is our ANSYS design modeler. So now in previous sessions, we designed our own surfaces and we created a laminate. So now I'm going to import a geometry. So for that, file, import geometry and open. So this is the geometry I'm going to use. Yeah. So .x underscore b file, it means a parasolid binary files. You can get these files from CAD softwares like SolidWorks and other CAD softwares. So once you import, you can see here, your file is imported and you are getting a flash symbol here. So once you get a flash symbol, you need to generate that, right? So once you generate, you will get your geometry. Here we have two surface bodies, one and two surface bodies, wedge and flame. So I'm going to convert this as single part. Using control, select two surface bodies and right click on that, form a new part. So now our geometry section is done. So close your geometry section. You can see a right tick mark in the geometry, and once you complete geometry section, move to meshing. So click on mesh. At the properties, you can see length unit. So I'm going to choose my units here. I'm going to choose here. So double click on the model. Whenever you select a model or geometry or setup, you will find a notification at the left bottom. So okay, in model section, we are going to mesh our part. So meshing is very important in and then stress analysis. So see here, our geometry, we are getting question marks here. So I'm going to give a fake thickness 1 mm for both surface body. So now I'm going to give a mesh. See, there are two options to mesh your geometry. Right click on mesh, you can go to insert and you can select sizing, or else you can go to mesh control and directly you can find sizing here. Click on sizing. So once you click on sizing, you will get details of that sizing. So geometry and what are the things you want here. So first you need to select your geometry, which part you are going to mesh. So I'm going to select body here, click on body, click on these two surface bodies and click apply. Now two bodies are selected. Our default element size here is 12 mm, right? So whenever you will go for small mm, you will get a fine mesh, but it will take lot of computational effect. So I'm going to choose here 5 mm. Now right click on mesh, generate mesh. So once the meshing is done, you can find here, see our mesh is not a structured mesh here. So for that, I'm going to use face meshing. So click on face meshing. So select all faces using control. So we selected all faces, and now click on generate. So now you will get a fine mesh. You can see a fine mesh here. You can go for even small elements, but it will take less. So once the mesh is completed, we are going to give a name for each and every part. So first I will select this part, select this three surface and create name select. Right click on that, create name selection. Here I will give a name flange 1 and select this three, right click, create name selection, flange 2, select these three and create name flange 3, and this, right click on this, create name selection 4. So top surface, and this select this 4 surface, right click on that. This is the surface where we are going to apply load. So force area, and now select this, right click on this, F1, and select this web 2. So now select all edges. For that, go to edge section here. You can see here edge, click on this. I'm going to select this edges. Right click on this, create name selection, and give name as edge. Okay. So now We gave name for all parts. Now will check this. So flange 1, 2, 3, 4 and force area, web 2 and edge. You can see this. So meshing part is completed. So if you have any doubt up to here, you can ask now. If I go speed, you can raise your hand. So I will. Shall I move to setup? Anyone have any doubt up to here? You can ask now, or else we'll move forward. Okay. So now our model is ready. See here, you can see a flash symbol here. Once you get a flash symbol, you need to update. So right click on model. So click on update. So now our model is updated. So up to now, it's all a common process for all materials. So now move to setup. So this setup section is the main section for our composite laminate design. So now you can see our surface. This is the mesh part. So in left hand side, you can see the descriptions of ACP model. You'll find material data, element sets, edge sets, geometry, and up to solutions. Right. So these are the parameters we are going to use to laminate. So first, see our materials. So these are the materials we selected in our engineering data. So here you'll find a flash symbol. So right click on this and click on update. Once you update, you will get a right green tick. So now your material is updated. So we are going to create a fabrics. So click on fabric, right click on this, create fabric. So first, the material we chosen is epoxy S glass. So I'll give you name epoxy S glass. So select that epoxy S glass and I will give a thickness 0.1 mm and I will click OK. Now again right click on create fabric. So we selected honeycomb. So honey, I'll give name as honeycomb. Choose your material honeycomb here and then I'll give thickness as 3 mm. So click on OK. So two fabrics we are going to use reinforcement for a laminate. To laminate we are going to use epoxy S glass and honeycomb. These two it's going to take loads, right? So right click on this and click on update. So now two section is over. One is we updated our materials and we created our fabrics. Once you create your fabrics, click on element sets. So these are the names what we given in our model. So update our sections. Right click on this and click on update. So this is our edge. So finally we choose an edge. So update our edge. So now we are going to create a rosette. So right click on this, create rosette. So once you right click on create rosette, you will get a dialog box this. See here you can see origin, direction 1, direction 2, whether it is a parallel or radial or cylindrical, whether you are going to use edge size or spherical. These are the coordinates. So what we are going to use, we can select for our analysis. So now first we will create a laminate for our web section. So click on origin and click somewhere here. See, once you click here, you will get an axis systems. So I'm going to change the orientation. For that, in direction 1, I'm going to give 1 year and I will give 0. You can see the change in the coordinate system here. So now click on OK. So our rosette is created. Now move to oriented selection sets. So now we need to select in which orientation we are going to fabricate our lamina. So right click on orient selection and create orient selection set. First I will give a name. First we are going to give a web in right direction. See here. Am I audible now?
Yeah, now you're audible.
Yeah. So
Dear participants, we'll get back. I think there's some technical issues from the end of Mr. Dhananjay. I'll be updating it soon.